This is Algebra 2 with Trig, 8C.1c. Again, we're going to talk about law of sines, and we're going to solve for all the parts. Solve the triangle, including the ambiguous case. So, these are some notes that would be helpful for identifying situations. So, anytime you have two angles, we're going to have one triangle that can be formed. When you have two sides and one angle, in this pattern, not side angle side, but the non-included angle, we have to be careful. If the given angle is obtuse, and the side opposite is smaller, then there is no triangle. If when you're doing your calculations you get an error, there is no triangle. And these particular notes right here are referring to a method of calculating the number of triangles based on angle values. We typically calculate our number of triangles based off of the side values. But just to fill out the notes, if you get an answer when you're calculating your angles and you're given an acute angle, then we're going to have two triangles. So let's come down. We're going to talk about solving these triangles based off of our sides. I notice that this is a 127, which is an obtuse angle. 127 degrees. If that is side A, or angle A actually, side A is going to be opposite. And then with the other side given, would suggest to write that always in this pattern. So we have our SSA, side-side angle, so that it follows the note patterns that we have talked about in the past. And those note patterns I'm referring to are on our first page. It has a flow chart that talks about what's happening with our situations. So here we have an obtuse triangle. So is the angle given to us obtuse or is it acute? It's obtuse. So if that angle is obtuse and the opposite side is greater, A is greater than the B, you're going to have one triangle. In this case, A was less than the B, you have no triangle. Our opposite side is greater than the other side. So we're going to have one triangle. This is an SSA situation, and we are going to have one triangle be formed. So we don't have to worry about multiples. Now it's time to solve it like we have in a previous lesson. Notice that we have two bits of information for the same letter. We have the angle and the side. That tells us that we can use law of sines. I, of course, have to use A because that's what I have both information for. And I need to solve for angle B because I have one of the parts of the fraction, but not both. I don't have the angle portion, but I have the side portion. So we know that 63 over the sine of 127 is going to equal 42 over the sine of b. So then we're going to need to cross multiply. That's going to give us 63 times the sine of b to equal 42 times the sine of 127. Then we'll need to divide by 63. Now sine of b is all by itself. So sine of b you need to be sure you're in degree mode. Got to be in degree mode. We have 42 times the sine of 127, and we're dividing that by 63. We get 5324. 0.5324. Now that itself is not an angle. We have to calculate angle B by doing sine inverse of 0.5324. So we'll do second sine of our previous answer. Use that answer button, or at least 4 decimal spots. And we get 3217. So the measure of angle B is 3217. So next, to find this angle C and side C, we're going to have to do another law of sines. Side C, actually, we can do that by subtracting. The measure of angle C is going to equal 180 minus what we already know for our 2 other angles. So that's 180 minus 127 minus 3217 gives us 2083. So the measure of angle C is going to be 2083. So what do we have to solve for now? Side C. So we do this one more time. If we're solving for side C, of course, we're going to need to use the fraction with C. And since we had both bits of information for A, we're going to use the fraction with the A. This is law of sines. We plug in our numbers. We don't know C, but we know the angle of C to be 20.83. Side A is 63. Sine of 127. We're going to cross multiply and divide. I'll do that all in one step so we can get this to fit. But we have 63 times the sine of 20.83, and we're dividing that by the sine of 127. That gives us a length of 2805. So we can put our 2805 right there. Now notice that we have solved for the 3 missing pieces when we were originally given 3 original pieces. All right, for our next example. We're given an angle B to be 52 degrees. The side opposite would be B. And we always want to put our other side here at this location. So that means angle A is sitting over here. Now, I haven't finished my triangle off yet because I don't quite know what I have. I notice that this is an SSA situation, and the side opposite is smaller than my other side. So I need to find the height. Find the height. So we're going to calculate the height. And the height is going to come right down your triangle. If you put your information in this pattern, the height is straight up and down as we would expect. So here you have your triangle. The sine of 52 equals the opposite side, which is your h, over your hypotenuse, which would be across from the right angle. So 6.5 sine of 52. And we can use our calculator to determine this. 6.5 times the sine of 52. Oh, gotta turn it on. You need to be sure you're in degree mode. 6.5 times the sine of 52 is 512. All right, so imagine this. This side here, it's not really a side, but the height of the triangle is 512. If the height is 512, and you have this part over here that is swinging back and forth trying to touch the ground at 4.7, it's never going to touch if the height of the ceiling is 512. It's too short. It's got to be longer than 512 for it to touch the ground. So this is going to have no triangle. The opposite side is shorter than the height. Now we'll come down here to this one. This is going to be the tough one. Here we have a 62-degree angle. That's angle A. Side A is 32. And that's side A. Side B is 34. And remember, we always do it in the order of angle, side, and side. We don't want to put the sides down here because then we don't know about the height. The height, we typically want it to be straight up and down. Now, we need to find the height in this case because the opposite side is shorter than this original side, or the adjacent side. So we have SSA, and we need to find the height. We need to find the height because the opposite side is shorter than this other side. So we do that by using this right triangle, and we have sine of 62 equals this opposite side, which would be called the height, over the hypotenuse, which is 34. So we have 34 sine of 62 equals h. So 34 times the sine of 62 is going to be 30.02. So imagine this. If this height is 30.02, what's going to happen with this 32?
It will,
With this 32 being longer than the height, it cannot stand straight up and down. It's too long. So it has to swing out. If it can swing out, it could actually also swing back in. So there are two locations that this 32 could be at. So we're going to have a triangle that looks just like the one we've drawn, with a 62, a side A of 32, and a side B of 34. We have to find angle B, we have to find side angle C and side C. We're also going to have another triangle with a shorter edge here. It's still going to have a 62-degree angle. It's still going to have a B that's 34. But instead of swinging out to be 32, it's going to swing in to be 32. Now, what is very interesting about these two B angles? We're going to calculate B here. This B is going to be the supplement of this one. And we can talk about it when we get closer. So, now we just go ahead and solve this triangle. Once you identify that there's two triangles, you still got to solve for all the unknown information. So we're going to use A over sine of A and B over sine of B, just like we have in the past. So 32 over the sine of 62 equals 34 over the sine of B, and that's what we're trying to find, is what this B value is. So we'll cross multiply to get 32 times the sine of B to equal 34 times the sine of 62. So we'll divide by 32. And we can put that into our calculator. 34 sine of 62 divided by 32, and that gives us 0.9381. So the sine of B is going to be 0.9381. Now that itself doesn't tell us a ton. All right? So we need to do the measure of angle B equals sine inverse of 0.9381. Sine inverse of our previous answer. See how I did that? I didn't just type in 0.9. I definitely didn't type in 0.94. You could do all 4 digits, or you can do the ANS, and that's the most accurate. You have 69.74. Those would be in degrees. So we can come up here and label our triangle. So that found the one part. Now we can find the measurement of angle C by taking 180 and subtracting the two angles that we already know. So we got 4826. That's our missing angle at the top. And then we have one more side to find. So we have C over the sine of C equaling A over the sine of A. I would suggest to keep using the A's because that was the original information that they gave us. We don't know C, so the sine of C is going to be 4826. 32 over the sine of 62. We can cross multiply. I'll do this all in one step. 32 sine of 4826. Divided by the sine of 62. That gives us 2704. Those are our three answers. 2704. All right, so we solved it just like we would solve for any triangle. Now, how do we figure out the measurements of the second triangle? These B values are supplementary to each other. Let me give you a little demonstration of why this is supplementary. When we swing this edge down, and if we have an option to swing it back in, this triangle has two legs that are the same length. That makes these two angles the same, because an isosceles triangle has base angles that are the same. So whatever this measurement is, let's call it the 6974. Well, this would also be 6974. That's not part of the triangle that we need. We need the angle on the other side. These angles are supplementary put together. So we can kind of skip this angle here and just do supplementary to those two. And we do this by 180 minus the 6974. And we get 110.26. So this angle here, the measurement of angle B is going to be 110.26. What do we need to solve for next? I don't even have them labeled in here. If this is angle A and this is angle B, this would be angle C. This would be side C. How do I get angle C? It's another 180 calculation. So you find out that this triangle goes pretty quick. This is 180 minus the 62 minus the 110.26. 180 minus 62 minus the 110.26. That's going to be a 7. Measure of angle C equals 7.74. And if you look at it here, it's not very big, so it could be reasonable for you to understand how that angle is going to be so small. These three angles have to add up to 180. Okay, what's our last thing we need to solve for? Side C, and we solve for side C the same way that we had been solving in the past. We can use law of sines because the two bits of information we have are the A's. So we're looking for side C. We're given angle C. We're given side A and angle A. We're going to cross multiply, then divide. I only have to cross multiply one direction. So 32 times the sine of 7.74. And we're going to divide that by the sine of 62. And we get 4.88. And if you look down here, this side is considerably smaller than what it was originally on this one. So it would make sense that it could be so small. There are your two triangles. What did we do? We came through here and we solved this triangle like normal. Then to start to calculate this one, we did the supplement of the original angle and came up with 110. And we did three angles add up to 180 to figure out our 7.4. And then we did one law of sines to find the missing side. There's a few questions for you to work on the back. I may do one or two of these. I'm not quite sure I'll get through all of them. You go ahead and try those. Pause the video. Work through those. See how it goes. All right, the first one I'm going to jump to is letter B. Let's see how this one works out. This is a 36-degree angle. It's letter A. Side A is 9. So angle B would be here, and this would have to be side B. Remember, we always want to put it in this order of side-side angle. When the opposite side is smaller than the adjacent side here, the other side, we need to find the height. So your height is going to come right down when you order it in this pattern. You're going to have sine of 36 equaling h, which is your height, over 12. So 12 sine of 36 equals your height. Sine of 36 is your 7.05. 7.05. That is your height. So this situation does look like it's going to create two triangles. The A value is greater than the height, but it's less than the other side. So we have two triangles. Our first triangle is going to look just like what we have drawn here, with the 36, the 9, and the 12. So we're going to do 9 over 36 equals 12 over sine of B. 9 sine of B is going to be 12 times the sine of 36, and we divide by 9. That gives us 78/37. And sine inverse of 78/37 is going to be the measurement of angle B. So we do sine inverse. That gives us a 51/60. That's the measurement of angle B. So 5160. The measurement of angle C is going to be 180 minus these two angles. So we're going to minus 36 and we're going to minus 5160. That gives us 92.4. So this is the measurement of angle C. Want to label your work. And we have one less side to find. So we have C over the sine of 92.4 and 9 over the sine of 36. So C is going to be those two multiplied together divided by the sine of 36. So 9 times sine of 92.4 divided by the sine of 36 gives us 15.3. So those are the three measurements we've just found. Now our second triangle is going to have the 36-degree angle. It's going to have B as the 12, but we're going to swing in. And when we swing in, we get this obtuse angle B. This obtuse angle B is supplementary to what we had originally up here for angle B. So 180 minus the 5160 gives us 128. So the measurement of this angle B is going to be 128.4. And to find angle C, we do the 180 thing again because we have two of the three angles. So 180 minus 128.4 minus 36 gives us 15.6. So the measurement of angle C is 15.6. And we're missing our last side of C. So C over the sine of C is going to equal A over the sine of A. And that's going to be our unknown over the sine of 15.6. 9 over the sine of 36. We've got a cross multiplying and a dividing by the sine of 36. So our missing side was 412. So you want to circle your answers. And that was another example of solving for two triangles. For example, C found that the height was 3.06 and 3.06 is longer than the opposite side, so this is going to swing and never reach the opposite side, so there's no triangle. Go ahead and try to figure out this last one. So work through the first example. We found out that angle B was 34.43. Angle C you would subtract from 180 with your two angles. that we already know, and we got 2357. And then we use law of sines to calculate side C at 8.49.